So, hi everyone, we are the Spaghetti Coders, and we would like to present you with our tool that we developed within this hackathon. My name is Štěpán Vondráček, and I did it together with my colleagues Stanislav Zámečník and Lukáš Dadák. Our tool is called Demosthenes. As you might know, he was a famous orator and debater in the ancient Greece, and he was famous that he could overcome his hurdles when he didn't know how to pronounce properly. He did really hard rehearsals with pebble stones in his mouth, and we actually thought it might be a nice, let's say, metaphor for our tool, because our tool is doing precisely the opposite. We aim to make it possible for participants in debates and discussions to give them concise information and make it actually easier for them to get prepared for such rehearsal. When we were researching some motivations for a tool as ours, we actually found out that there's a lot of times cited the Pareto principle, that actually a lot of percentage of time for preparation is spent with news articles reading and going through a lot of distinct sources, crunching a lot of, let's say, noise. And actually, it takes time to get to really important stuff. So that's what we tried to overcome with our tool. That was the main motivation. Also, the economics of preparations for debates, for politicians, is very costly. It costs to hire analysts, some advisors, and so on. And that's what our tool actually is also aiming to somehow ease from the, let's say, budgetary perspective. And hereby, I will hand over to my colleagues who will show you real time how our tool works.
Okay, so now we'll go through the application quickly. So right now we are on the dashboard of the application. We can see top opponents that we faced or will face in the debates. You can see a calendar with the upcoming debates. And so right now we can select one of the opponents, see his profile, his description, debate style, known positions. And also we have advanced media tracking turned on, which is a knowledge base which is fed with articles from Newsmatics, and real time. Right now, it's generating the historical basis, but it's also updated real time. And then we can also see time frames. We can see how much the opponent was mentioned in the articles. However, the main use case of the application is to create so-called preparation for the debates. So we can start with that. We define the data about the debates, the opponents that are taking part, and so, for example, I can select Donald Trump and analyze timeframes, which lets us analyze where to find the topics from each time. We can also add other topics of the debate and stuff like that. But this generation would take pretty long time. So we will switch to already generated debate. And this is a debate about Russia with Donald Trump. We can go through the winning strategy, which is created based on all the topics which are generated by AI or by LLMs when the preparation is created. It consists of sneaky questions, arguments, and why the topic is bad for the opponent, and why do we need to talk about it. And all of this is sourced, so we can open the sources that are used in the topic, and actually look at the sources of the claims. So, and all of this can also be exported. So when we need to hand this to a candidate or a politician who wants to use this at a debate, yeah, we can export it to PDF or whatever file. Well, okay. Yep.
Just briefly show.
So, closing arguments, please.
Okay, so the tech stack that we used, as you heard, bunch of LLMs, React for frontend, Python for backend mostly, and yeah, so I guess we'll be able to answer it later in your Q&A now, what we actually use for technology.
Okay, the first question, can you please? Can you please elaborate more about the processing pipeline, how it looks like? I know that you are getting the data from our API, but you are mixing it together with some other sources. How you do that? How it looks like?
Yeah, so I guess I will start. So first of all, as you've seen, we make the user able to actually specify what should the query actually look like. And we specifically use two endpoints of Newsmatics API. First of all, we want to look at the, let's say, the article count endpoint to actually determine what time frame is relevant for the query, so that we try to identify spikes. There's some like very primitive outlier detection or like anomaly detection algorithm behind that's able to determine the spikes. Then we make the user able to filter out what should be the time frame for the query. And with this time frame, he actually goes to the next endpoint, which is the hybrid endpoint, I think, is it called, where we actually use the text, where we like chain the information from the input, like the targeted, let's say, opponent, and the keywords that we are actually interested in. That way we obtain information from Newsmatics via the API call, and then we actually, once we have the real sources of the, let's say, of our information, then we then use only the LLMs to actually create some like analysis based on what we obtain from Newsmatics. If you want to make any remarks more specific, or if this was enough as an answer.
Guys, so how was the knowledge graph constructed? Which method was used?
We used a library called LightRag, and we basically used all the functions of it. It's basically constructed by an LLM. We know how it works, but we didn't implement it. It's a library. But the nodes, the entities, are extracted with an LLM from the chunks, and then we deduplicate, or the other library deduplicates the nodes against the graph, also the edges, and constructs a graph from the ingested documents.
Mm-hmm. And on the specific data you had, did you use Ragas for some sort of validation?
Sorry?
Some method that was in LightRag that would allow you to validate how well is the pipeline performing?
You mean the whole pipeline, or the graph generation, or?
Yeah, well, whatever test you did, I mean,
No.
like in the time frame, I know it's very hard to do.
Our validation was basically just going through the results of the preparations and checking if it makes sense.
Okay, thanks. Okay, that's all the questions. Thank you, guys.